In this spreadsheet, I've recreated one of the exercises available on my educator because I actually don't like the way that they're doing their statistics, and I think it can throw you off. So I'm going to do it the way my educator tells you to do it, and then I'm going to do it the way I think it should actually be done. So here we have temperature and sales. So think about temperature and ice cream sales. Let's find the correlation between the two. So to do that in B13, we are going to use the correl function. Two arrays. The x is going to be the temperature, and the y is going to be this. Oops, I'm dragging instead of selecting. Let's start that over. I'm not sure. Oh, I put a period. Okay, 8, 2 to 12 is good. Array 2 is B2 through B12, so that's good. Oops. Fat fingers today. Okay, so correlation, very high correlation. That's very good. So let's do some basic statistics here. Count. So count counts in numbers. All my data is in numbers. So it's going to be the same for sales and temperature. Average. We're just going to use the average function. So average temp is about 70 degrees. Average sales are going to be around 4,000 to 5,000. So $5,186. So the standard deviation here. So in this example, let's just assume that this is not an exhausted list of every day. So it's just a sample of temperatures and sales for those days. So we'll use standard deviation.s. And I'll choose the array of temperatures. So the average day, differed from our sample average by about 17 degrees. It's basically what that's telling us. And our sales, how much did they vary? So it's $5,000 plus or minus 1,200. Basically what that's telling us. So our confidence interval, we'll use the confidence.norm function. So our alpha, we're just going to hard code that at 0.05. Standard deviation, we already calculated. And the size is the count. Okay, so the confidence interval is 10. So that means to do the upper estimate, we'll take our average and we'll add the confidence interval. And the lower estimate, we'll take our average and we'll subtract the confidence interval. So this means that I'm 95% sure that the true average temperature for my ice cream store was somewhere between 60 and 80 degrees. That's a pretty big interval, but hey, there we go. That's what our data says. We don't have a very big sample size, and it is varying quite a lot. So it is what it is. So let's do the same thing for our sales. We'll use confidence.norm 0.05, standard deviation, and sample size gives us, $725 confidence interval. So to create the upper estimate, we'll take our average and then we'll add that confidence interval. For the lower estimate, we'll take our average and we'll subtract the confidence interval. So that means if I were to look at all of my sales for every single day of this ice cream store's history, the average daily sales would be somewhere between these two values. Okay, so we want to see, using this data, what will my ice cream sales be when it's 70 degrees? So I'm going to use forecast.linear. So x is the new x. So my new x is going to be 70. And then known y's will be all of my previous sales. And the known x's is all of those temperatures. I think it's backwards to put x, known y's, the known x's. My brain thinks x, known x's, known y's. So just pay attention to the prompt there. Okay, so this tells me that my predicted sales, if it's 70 degrees, is $5,234.15. Now, I know, so that's down to the penny, but I know there's going to be some error in my estimate because my data is not that consistent. So I need to correct for. So here's where I differ with what my educator does. So to count using my educator's method, we just create a reference to our confidence interval for our sales, that Y variable. So the lower limit will be our forecast minus that confidence interval, and the upper limit would be the forecasted value plus the confidence interval. So we're saying, okay, if it's 70 degrees, our sales are, I'm 95% sure that our sales will be between $4,500 and $6,000, rounding a little bit. That's what my educator has you do. The only issue that I have with this is that this confidence interval is just looking at the variance in one of our variables, sales. It's ignoring all the variance in temperature and the relationship between these two variables. There's another statistical measure. It's called the standard error. And this looks at the relationship between those two variables and tells us basically how consistent it is. There's an STEYX, standard error of the predicted Y value for each X in a regression. A regression is basically what we've done in the forecast.linear function. So here we have our known Y's, sales, and our known X's, temperature. And this gives us a standard error of $487.17. So what this says really is that if you looked at each one of these values, each one of these temperatures, and tried to predict sales, you're going to be off on average by about $487. So that is different than the confidence interval of our sales. Okay, so doing it my way, I'm going to take my estimate and I'm going to subtract my standard error. And using the upper estimate, I'm going to take my average and I'm going to add that standard error. So I have a much more, well, a couple $100 tighter confidence between my lower estimate and my upper estimate. So why does this matter? Well, I'll just promise you this is the correct, using the standard error is the correct way. That's the good way. Doing it this way, the numbers aren't so far off in this example where it makes a big difference. However, you could have quite a bit of variance in one of your variables, but a very high correlation between the two, and you would get very different results. So use the standard error when you're trying to determine how accurately one variable predicts another.